After I got done with that last video, I went to do the final editing and do the upload, and it was kind of long, and I cranked up the resolution because one of the viewers said it wasn't coming through as clear as he would like, and I agree with him. So I cranked up the resolution, so it takes longer to load, and I started loading, and it said 48 minutes to go. And so I thought, well, I'll walk over here and do some more work or something. Well, when I get here, there's no side bolts in the block. And I said, wow, how could I forget that? You know. So I had to think of a good excuse, and my excuse was, you know, Joe's trying to convert me to a wedge man, and I don't have to think about these. But, you know, because we don't want to admit that we make mistakes. I mean, I sure wouldn't admit to anything like that. But I can make excuses. So I thought, well, just for fun, and I believe I've done this before, and it wasn't such a big deal. But I found this interesting. I'm thinking this one was 41 and a half. I mean, you wouldn't think these cheesy little side bolts are going to change anything, especially with these huge webs here. But now this one is 41 and a quarter. Wasn't this one 41 and a half a while ago? I mean, I just can't believe it tightened it up that much. But it appears that it did. And this one, wasn't it 41 and a half too? Now it's showing 41 and a quarter. I'm a little amazed. Don't tell anybody, you know, that I forgot these. Just lay low on that. And this one was 42 something, wasn't it? I can't see it because I'm still uploading. This one was 42 something. And now it's 41 and 3/4. Very interesting is all I could say. I mean, I thought I'd check this once just for fun, and I didn't find anything, but it made a change. I mean, you know, this was, what, 30 minutes has gone by, so it's not like we have a temperature change here or anything else. I don't know, I'm amazed. The owner said the cam bearings looked beat up. I guess that's okay, because when you line hone something, you ruin the cam bearings, because that's what you hold the block down with. The last block I did must have been for Joe, and must have been a low block, because I had to reset everything up, and then you have to readjust this, because low block is a different main bearing size. Everything's set up now, and it's looking good. You have to test this and make sure that that works out right. And it's right on the money. So we're good there. Now this shouldn't take much to do, because we're not honing much out. And once I get that record player groove out of the mains, I mean, I think we're going to be there. I bought 4 of these blocks in early 2000, and they were all the same way. I was only going to use one of them, and I had to take it and have it line honed, because that was before I bought this. And they were all terrible. So this is really as to be expected from these blocks when they were made. This is still my favorite block, even with its faults. I like them. You know, they're more of a Mopar instead of a aftermarket. I mean, Mopar didn't cast them, and Mopar didn't machine them, I think. Motor Castings up in Michigan cast them, and Cummins, I think, machined them. But they did a pretty terrible job on some of it. It's going to be better now, and it should be fine. We just have to get after it a little bit. Of course, I'm dreading changing the cam bearings after the cam bearing problems we had on 3 engines in a row a couple months ago. I sure hope we have good cam bores, because that is a nightmare. Let's get after it. It does feel better. After just that, it went to 42, 42, 42, 42 and a quarter, and this one was 42 and a half, because that was the big one already, you know. So, but we're catching up to that, that's exactly what we want to do. It's not going to take much more to get where we want to be. And that was enough to get the job done. The numbers are all good, all within the range. And, you know, when they cut the caps 3/1000ths and line home, you get all fresh metal coming up. Of course, I really don't want to remove any metal, or as little as possible. I'm not wanting to change anything, you know. It didn't take much, which I didn't expect it to. And you know, really, like those blocks I had and this Cummins block, they really would have been perfect if it wasn't for the groove left in it. I don't know if that's a dull tool, bad tool, whatever you want to call it. The 0 is the high side, and this is, well, it's hard for me and you to get, okay, that one is 3/10 lower than the high limit, which puts it exactly in spec. The spec is, you know, half. This one is dead on 0. This one is, that number 4, you know, it started the biggest, and so that was good, and that's why these others are smaller. And this one is 3/10 below the high spec, which is perfect. 3/10 below the high spec. And 1/10. No, we got, well, let's try it again. We're somewhere between 1 and 3/10. Between 1 and 3/10 from the high spec. So it came out perfect. One thing you and I have to wonder about is, look at those main bearings. Now those main bearings were in a hole that was a thou tighter than they're made to work in. Is that why we see that in the middle? We don't know. We're not bearing engineers, but you have to stick your bearings in the right size hole if you want them to perform as bearings as intended. Look at those lines right there. Is that the lines of the record player groove in the main bores? That's kind of interesting. I've got the engine back on the engine stand, and I went ahead and knocked the cam bearings out since we ruined them anyway. And now I've got my card out that tells me what the cam bores are supposed to be. And they better be right. I mean, after all the problems we had on 3 blocks 1 or 2 months ago, I can't take it again. It just has to be right. I won't make you sit through that. I'll do them. What a disaster. There's not a one of them that are in the spec. That's what the bores are supposed to be, and that's what they are. Half a thou under the low limit, half a thou under the low limit, half a thou under the low limit, half a thou under the low limit. And that's the worst one. It's 1 thou under the low limit. If I would have paid some tool and die shop a couple thousand, I'm guessing they would have made me some reamers a couple months ago when we were having all those cam bore problems. But instead I spent way over that buying all that Hona equipment, and it's tough with the Hone. I need the reamers. I don't even know if there's a shop around here that'll make them. I'm going to investigate. Listen to this. We've got that same vinyl record grooves in it. I need to buy Cummins some tooling where it'll do a better job of cutting that out. They're probably all perfect once you, just like the main bores, once you get that groove out of there. Wow. Did I ever tell you nothing's easy? This was supposed to be a fairly easy job, but no, it's not going to be easy. I'll have to do some ciphering on this. Some of the problems finding bearings for this engine, I'll try to explain this. This is what a stock crankshaft looks like. Let's kind of focus on this part right here. This is called undercut, and you can see the plunger comes straight down, comes over, comes straight up when they grind this. And looking at this, you can imagine that this would be stronger, of course, if there was a radius right here. And that's what you call a full radius crankshaft, when it's got a radius here and over here for the mains. All stock crankshafts come like this. High quality, high horsepower capable crankshafts going to have a big radius here. So keep this on your mind while we talk about finding bearings for this engine. This is an undercut crank, stock crank, 426 Hemi, max wage, whatever. And then we're going to go to a full radius crank, and you're going to see why it causes a problem on the bearings. Now we're looking at the crankshaft out of the crate motor 426 Hemi, and you can see the big radius here, and you can see how much stronger that looks like. They used to call these Kellogg cranks. That was the brand that Mopar used to sell. I guess a better technical name would be a full radius forged crankshaft, but anyway, that's where the radius is. Now you can see where this is going to cause a problem. You think about that bearing in that rod. Well, this radius is going to interfere with this rod sliding all the way up to the side. So you have to have narrowed bearings. And sometimes they're not narrow enough, if you know what I mean. But this is why you have to have narrowed bearings
with a full radius crankshaft because there's not enough room. Because your effective working length is really, or width is really from here to here, because you can't go all the way to here without a narrow bearing, assuming the bearing was similar to the width of the rod. That's why I'm having problems finding some bearings for this engine. So now it's time to start looking for some main bearings for this engine. You've seen the full radius on the main bearings of the crank. What that does is it eliminates most all of the original OEM bearings, because if you try to put the crank in there, it won't turn. It's interference on the full radius of the crank. So that takes those bearings out, and then you think, well, here's a bunch of other numbers I can look up, but the Mopar 426 Hemi engine book says to use full groove main bearings. Well, guess what? I want full groove main bearings, and all of those are going to be half groove or 3/4 groove. Now, I know people put engines together every day with half and 3/4, and they go 10,000 RPMs and last forever. But the book says full groove. I want full groove. And then there's the Clevite 1277 HG, which sounds like the perfect bearing. It is a H bearing, which is a higher performing bearing, which is supposedly radiused enough for the crankshaft, for a full radius crankshaft. It's full groove. It's everything you want in a bearing. It's a large flange thrust, but that's not a problem because Mopar blocks after the 73 model year went over to the large thrust bearing. Now, even though that the Street Hemi went out of production in 71, they continued making blocks for replacements and top fuel and drag boats and race cars and everything else. So they went to in other words, Hemi blocks are machined on the line at Trenton, the regular BRB line that machines everything. So the cars 74 model year have the large thrust. But since the last Hemi blocks were cast at Mopar in 74, you'd have to have a block. The only ones with large thrust are, say, spring or summer of 73 up until the end of production in 74. But since this block was made after that, you would think it's large thrust bearing. Well, think again, because I guess when Mopar sent Cummins the print to machine these by, they just sent him the original Hemi print, which is the small thrust. So now that won't work here either. It's not easy. I would like to have one of those Tobernarp line bore machines like every shop in the United States used 50 years ago, because that would be one good thing that you could do with it, is set up and just cut that further back for large thrust. Of course, I don't know where I'd find an 80-year-old to show me how to run it. If I had a machine, I don't know what I'd do with it because I don't know how to run it. But that's what I need, is a Tobernarp line bore machine. Then I could just cut that thrust back. Not that we need large thrust, but times like this, when the bearing that you think you would like to use is a large thrust, that's the time that I would use it. But you really don't. The block, you're trying to make the block happy. Because if you stick a bearing in there that you like, you think, well, I like this bearing, I'll put it in there. Well, you can put it in there if you want, but the crank won't turn. The block will tell you what it wants.